welcome back. So we draw this out, roughly, cracking looking circle, there we go, so that's our circle. So there is a tangent, which is a straight line that touches the circle just once, that goes through the point 6, 1, okay? And we want to find the equation of that tangent, so we'll write down y equals mx plus c, because that's the equation of any old straight line, and then we can find the gradient and we can find the y-intercept and we're done, okay? Now the best way to do this is to draw a line out from the centre of the circle, because we know where that centre is at 1, -4, out to the point where it meets the tangent at 6, 1. Now the reason to do that is because from your circle theorems you might remember that the radius meets the tangent at 90 degrees, okay? So if I can find the gradient of this radius here, I need to switch the cursor, and this radius here, I can find the negative reciprocal of that, because this tangent is perpendicular to it, okay? So let's find the gradient of the radius. So we draw a little triangle out again. In the x direction we go along from 1 for the centre up to 6, so that's a distance of 5, and and we go from -4 up to 1, which is also 5. Okay, so the gradient from that line goes along 5, up 5, so the gradient is 1. Okay, so m equals 1. Now that means that the gradient of the tangent would be 1 divided by 1, and then make it negative because going opposite directions, so that's just -1. Okay, so that's a negative reciprocal. Had the gradient been 3, then the gradient of the tangent would have been -3rd. Okay, so reciprocal 1 over and then negative. So we've got y equals minus x plus c at the moment. So now I need to find c. Well, that's fine because I know a point on my tangent is 6, 1. So I put that information in. Y is 1. Probably hear that little tune from my next door neighbour's child. Y equals 1 and x is 6, so you've got -6 plus c. So then c must be +7, or -6 add 7 equals 1. Okay, so the equation of my tangent is y equals minus x plus 7. And then I think we're on finally, aren't we already? Oh, nearly there, yeah, 2 more. So for this one then we want to find, so if the line intersects the circle at point A and B, find the points of A and B and then find the length between them. So this is just simultaneous, it's quite nice, it's just simultaneous equations, so it's a skill we've hopefully already met. So we might go about saying, okay, well, we'll say y equals 5 minus 3x, just from rearranging this equation here. And then we'll just substitute that in everywhere we see y there into this equation. So we'll have x squared plus 5 minus 3x minus 4 all squared equals 17, which is x squared plus 5 minus 4 is 1, so 1 minus 3x all squared equals 17. Expand that bracket, so we get 1 minus, so I can't concentrate with that, so minus 3x, so we get plus 9x squared minus 3x twice, so minus 6x equals 17. And then if I expand that, we get 10x squared minus 6x. And I've got plus 1 on this side and 17 on this side, so I'll take away the 17, so we get minus 16 equals 0. I'll divide it by 2 to get 5x squared minus 3x minus 8 equals 0. And then we just need to know what the coordinates of A and B are, so just need to solve this. So pop that into your quadratic formula, or an equation solver on your class whiz. Let's see what we get. Okay, so we should get x equals 1.6 and x equals -1 from that. And then we want the y values that go with those, so we substitute them back into this equation here. So y would equal 5 minus 3 times 1.6, and y would also equal 5 minus 3 times -1. So our y values are So our y values are 0.2 and 8. Okay, so then it says calculate the length of the chord AB. So another little drawing will help you out here. So we now know what the values of A and B are. So A is at, let's say, here, so -1, 8. That's not very good actually, let's put. Let's have that up. Where can we have that? Let's have it here. So that makes more sense, doesn't it? So we've got -1, 8. For let's call that one A. And then for B, 0.2 and 1.6. Okay, so then to find the length of the chord between those 2 points, so then the distance in x coordinates between -1 and 1.6, which is 2.6 that way, and the distance in the y coordinates is between 0.2 and 8, which is 7.8 in that direction. So we just do 2.6 squared plus 7.8 squared and square root it. We get the length of the chord, 8.2 for that one. Okay, and then finally, show that something is a tangent to the circle. So actually at A-level we'd expect perhaps a slightly different response from what, oh, it does have, yeah, so they do discriminant. So if we have a tangent to a circle, or if this line is a tangent, then if we try to solve to find where they intersect, it's not a very good picture, there we go, we would find there's only one point of intersection, so there's only one solution to the equation if I sub this into this. So we're just going to have to kind of get on with that bit to see where it takes us. So we can say from this that y equals 2x plus 11. So we'll sub that in. So we've got x minus 5, tree seems to be shaking outside, x minus 5 squared plus 2x plus 11 minus 1 all squared equals 80. So we expand this, we get x squared minus 10x plus 25 plus, this will change into 2x plus 10. So we're going to get 4x squared plus 40x plus 100 equals 80. And then tidying all that up into a quadratic, we'll get 5x squared plus 30x. Let's get rid of these as we go. Plus 125, take away 80, so plus 45 equals 0. So now we just want to show that this only has one solution. So we've seen this in previous videos. That would mean that b squared minus 4ac would equal 0. There's only one solution, so the discriminant of the quadratic formula would be 0. Quick look at this again. There's the quadratic formula. So if this bit's 0, it's minus b plus or minus nothing, which will just give us one answer because I'm not adding or subtracting anything. Okay, so that's this here is our condition for one solution. So if we put in our values of b, so b is 30, so we do 30 squared minus 4 times 5 times 45, we should get 0, really hope we do. Yeah, and of course they're both 900, so 30 squared is 900, and 4 times 5 is 45 is 900, so that does indeed equal 0. So there is indeed, 2x minus y plus 11 equals 0 is indeed a tangent, and you just write a sentence to that effect there at the end. Camera's gone funny there, hasn't it? Okay, so I'll also post the solutions to all of these. If you've been through all of these, you just have a look through them as well. Just pick and choose the ones that you actually want to do. And I'll post this on Show My Homework so that you can see this video.